The title slide for Chapter 6 shows a crowded street in China. Together, China and India have 36% of the world's population, and the resource use per person in these countries is projected to grow rapidly as they become more modernized. So the chapter starts with a case study. Are there too many of us? With some interesting statistics. 1.6 million are added each week, an estimated 2.4 billion more people by 2050. So the question is, can the world provide adequate standard of living without causing widespread environmental damage for all the people on the planet? Some analysts suggest that there are already too many people collectively degrading Earth's natural capital. So a couple of questions divide the population into two separate groups. So one might ask, is it the 82% of the population in developing countries? So is most of the impact coming from the poor folks who barely or don't even have their basic needs met? Or is it the high resource consumption in developed countries like the United States and some of the Eastern European countries? Other analysts suggest that technology has allowed us to overcome the environmental resistance that all populations face and will continue to do so. So that's a real question. Can we continue to rely on technological innovation to continue to support this growth? Some suggest that we need to make effort to control population growth. And there are groups that are opposed to this. They say it violates their religious and moral beliefs, and others say that it's an intrusion into their privacy and freedom. Proponents of the slowing of or stopping of population growth point out that already we are not providing the basic needs for 1 in 5 people on the planet. That's 1.4 billion people do not have their basic needs met, like adequate food, sanitation, clean drinking water. They warn of serious consequences, such as, or most of the big idea here is that death rates will increase because of declining environmental conditions, which we already see in parts of Africa and some of the sub-Saharan countries. And resource use and environmental degradation increase in developed and rapidly developing countries, which results in increased environmental stresses, including infectious diseases, biodiversity losses, water shortages, traffic congestion, pollution of the seas, and climate change. So section 1 of the chapter, how many people can the Earth support? We do not know how long we can continue increasing the Earth's carrying capacity for humans without seriously degrading the life support systems for humans and many other species. So the human population growth continues, but is unevenly distributed. 3 major factors account for the increasing population size. First, humans moved into new habitats and climate zones, early populations of humans. Then early and modern agriculture allowed us to feed more people. And then medicine and other controls of infectious diseases, improved sanitation system, antibiotics and vaccines helped improve survival rates and reduce diseases from spreading and killing lots of people. You can see the figure there on the left shows this J-shaped curve here. And you see for most of the time the human population had a slow growth, and continued to grow very, very slowly. And then there was a major dip here in the Middle Ages during the Black Death of the Black Plague. Major dip. Millions of people died in Europe. And then after that we see this J-shaped increase. And we're right about here right now. We just hit 7 billion people. So what you see in the dotted lines here are these projections. The demographers, depending on certain factors, suggest that we'll be somewhere between about 8 billion to 10 billion people by the year 2100. This is a timeline of significant events in human history, starting from 10,000 BC to about 2008. which was when this book was published, and then you see some projections down here. So about 50,000 years before, or BC, human population was about 1.2 million on this planet. We were a hunter-gatherer society. About 10,000 BC was the last ice age. It was also about the time that agriculture began. And there we have about 4 million people on the planet, or 4 million humans. Then as the agricultural revolution began to feed more people, we start to see the human population increasing tremendously, 5 million, 100 million people. In the Middle Ages, the Black Death killed 75 million people. And we still see continued growth, a rebound from a significant number of people dying. Industrial Revolution begins in 1750, 791 million. There was a big famine in Ireland, Irish potato famine, 1 million people die there. There were between 1 and 2 billion. And in 1943, penicillin was the first antibiotics. So we start to see control of disease with antibiotics. And then in 1952, the pill was invented as birth control. And then there was a great famine in China, where 20 million people died in 1957, but we see that human population is continuing to grow. 3 billion, 4 billion, 5 billion, 6 billion, about I guess we hit about the 6 billion mark in about 1998. Only 12 years later, we're now at 7 billion, so we see this power of exponential growth. And then you see the projections out into the future, hitting 8 billion, 2024, 2042, 9 billion. And again, the numbers that we reach depend on the models, what the assumptions the models are using. So the rate of population growth has slowed, but it is still exponential, growing at an annual rate of about 1.22%. Most of this growth is occurring in the developed countries. But what does this translate to in terms of numbers? 82 million people were added in 2008, as an example, and at this rate, which amounts to about 225,000 new people added to the population every day. Growth is unevenly distributed globally. In 2008, 1.2 million people were added in developed countries like the United States and some of the European countries, and that translates to about 0.1% annual growth. The rest, 80.8 million, were added to developing countries, and this translates to a growth rate of about 1.5% annually. Projected population size is between 7.8 and 10.7 billion, and this depends on the average number of babies women are likely to have. 97% of this growth will occur in developing countries where there is acute poverty. Which brings up the point, if we see slower growth rates where we have developed countries where there is no poverty, then one way to slow down growth rate would be to help those countries get out of poverty, which should result in a decrease in the growth rate of those populations. This is just a graph showing the projections beyond maybe 2008 or so when the book was written. We're already in 2011, so we've already hit 7 billion. And then you see the low projection and the high projection and the most likely projection of 9.3 billion by the year 2050. So in this century, demographers, or people who study populations, expect a J-shaped exponential curve that we just saw to shift to a logistic S-shaped curve because of various factors that limit growth. So question, how many people can the Earth support indefinitely? Some experts say 2 billion, in other words, we've already passed that mark. Others say 30 billion. But with the current food production globally, if we added up all the calories grown in grains, we're only able to feed about 10 billion. So there's already a limit set with current food production. So perhaps a better question might be to ask, what is the optimum sustainable population? So we would call that cultural carrying capacity, which is the optimum level that would allow most to live in reasonable comfort and freedom without impairing the ability of the planet to sustain future generations. So the book has several of these science focuses throughout their chapters. And this particular science focus says, or asks, how long can the human population keep growing? So it gives some interesting points. It says that humans have altered 83% of the Earth's land surface with the help of the technology to meet our growing needs and wants. Can the human population grow indefinitely? Studies of other species show that no population can grow indefinitely. So how long can we continue to increase Earth's carrying capacity by sidestepping many factors that sooner or later limit the growth of any population? Early on, an economist, a British economist, Thomas Malthus, pointed out that while the human population growth rate was exponential, the growth in the food produced was linear, meaning that at some point the human population would exceed our ability to feed ourselves. So far his predictions have not panned out because, as it turns out, with every new agriculture revolution, we've managed to continue to increase food production at an exponential rate. However, some experts are pointing out that we are starting to lose arable land, which is land where you can grow crops and food for people. The climate is changing, so there is some concern on whether or not we can keep up with the demand for food globally. And we already see some areas that on the planet that are incapable of or cannot feed themselves and have to import food, either because the conditions there are not adequate for growing food because of that climate, degraded soil, or because, like in the case of China, the population is so large that they cannot grow enough food, so they have to import that food from other exporting countries. So actually no one really knows how close we are to the environmental limits. There's mounting evidence that suggests we are degrading the natural capital that keeps us and other species alive and supports our economies. This is just a figure in the textbook 6A that shows how humans are altering natural capital to meet our needs. They include reducing or the reduction of biodiversity, increase of the use's Earth's net primary productivity, increased genetic resistance of pest species and disease-causing bacteria, the elimination of many natural predators, the introduction of potentially harmful species into communities, using some renewable resources faster than they can be replenished, interfering with the Earth's chemical cycling and Earth's energy flow processes, and relying mostly on polluting and climate-changing fossil fuels.